Okay, when we were on to write number 11 as a summation, we first need to know that summation is the Greek letter sigma that has a couple of parts to it. The first part is where we start. On the bottom is the start spot. And the top is where we end. How many terms are we actually plugging in? And then the last thing we need is the equation that we use to generate each of these 5 terms in this case. So what we're plugging in are the numbers 1, 2, 3, 4, and 5. So we're going to start at 1 potentially. And because there are 5 terms, we're going to stop when we plug in the 5th term. So now all we have to do is think about the equation that we need to generate these numbers. So we started with a 1 and it became a 2. 2 became a 4, 3 became a 6, 4 became an 8, 5 became a 10. So hopefully you're familiar with multiplying every number by 2. So 2 is 1 times 2, and 4 is 2 times 2, and 6 is 3 times 2. Now that takes care of the numbers themselves. So the question becomes, what do we have to do to make our sequence or our series oscillate from positive to negative? Okay, and there's of course one thing that we always do, and that is we manipulate it by multiplying it by -1. Okay, so we will change this from time to time based upon whether we want it to be positive or negative. And because it starts off being negative, we're just going to raise it to an odd power. Anytime we raise a negative number to an odd power, the answer is a negative. And anytime we raise a negative number to an even power, the answer is a positive. So if I'm raising -1 to the first power, this is going to be a -1 times by whatever this thing happens to be. And when I raise it to the second power, this is now a positive. This is now a positive value, and I'm timesing it by whatever this happens to be. Then I raise it to the third power, and this is now a negative times whatever this happens to be. So if you want your equation to oscillate from positive to positive to negative, we need to include this multiplier that all it does is changes it from a +1 multiplier to a -1 multiplier. If we wanted it to start off positive, then we would raise it to the n plus first power so that every odd power became an even and every even became an odd. So depending on where it starts, you're either going to raise it to the n or the n plus 1. Now down here a little bit more, if we want to write this as a summation also, we start by writing the sigma. Okay, and now we have to figure out an equation for this. Okay, notice it has a dot, dot, dot at the end, which means it's never going to stop. So infinity goes at the top of our sigma. And we're probably going to be starting at 1, because that's just general. We start at 1. Sometimes you can start at 0 if you want to manipulate your equation, but for the most part we start at 1. So now we have to come up with the equation that generates each of these terms when you plug in 1, 2, 3, 4, 5, and all the other positive integers, okay, the natural numbers. So hopefully you're noticing right away that you have a fraction. So our equation is going to have a fraction in it somewhere. So let's start off by writing in the fraction bar. And deal with the stuff that is relatively easy. Okay, so on the top we go from 1 to 2 to 3 to 4, probably to 5. That's just the same as what number we're plugging in. So the top is just n. If I were to plug in the 9th term, the top number would be a 9 if we were to follow this pattern. Now the bottom numbers are going to have a little bit different manipulation. Okay, and you really have to recognize the different patterns that we have here. So 2, 5, 10, 17, that's not a very recognizable pattern. But what if I were to write down 4, 1, and then 4, and then 9, and then 16? That is hopefully a much more recognizable pattern, knowing that these are all your natural numbers squared. Okay, 1, 4, 9, 16 are just n squareds. Now 2 is really close to 1, 5 is really close to 4, 9 is really close to 10. So if I were to simply add 1 to each of my n squared terms, I believe that would give me the sequence in question. Okay, so when you're trying to write an equation, this part, you need to think about the patterns that you have learned in math and how closely these other numbers apply to that pattern if it is not directly related.